All right. Well, thank you, Lance. Much appreciated. Um, like you said, I'm Hayes Hutton, and I'm here to talk about real-time cloud security at scale with Neo4j. So, thought I'd start a little bit of background, let you know who I am, and then we want to talk about a mental model that I use in order to kind of frame the conversation as we move forward and place the demo within one of our particular security systems that we use internally at Palo Alto. So I'm a cloud architect. I've worked for Microsoft, IBM. I've done startup stuff on AWS, been doing data warehousing and analytics for 20 some odd years. So what I wanted to talk about here is I want to start with kind of a mental model and place the demo that I'm going to show you in a framework that I use in order to really give some context as to what you're going to see. So I started a journey about 6 to 9 months ago inside of Palo Alto Networks. My innovation team got tasked and paired up with the InfoSec team, our internal InfoSec team. And we were tasked with helping our InfoSec team come up with some more and innovative tools. And one of the things that I ran across about that time was a quote from a fellow, and this is quite an old quote, actually, talking about how defenders think in lists and attackers think in graphs. And as long as this is true, he thinks attackers win. I think this fellow's out of Microsoft Research, if I remember correctly. Anyhow, it struck home to me because one of the things that I really noticed when I watch what an InfoSec team does and these security teams is they really do use a lot of lists. And I think it's a lot about the tools that they use and the abstractions that those tools use. And I'm going to talk about a lot of that today. And I think graphs are a great answer to some of the problems that I think come up here. So first thing I'm going to do is I'm going to digress a little bit before we get into looking at the demo. I want to talk about this fellow named John Boyd. John Boyd was a military strategist, he was a fighter pilot. I think they called him 42nd Boyd. I think he kind of worked at the original Top Gun, and he said, I'm going to be able to get you in 40 seconds, no questions asked, always. He helped create the A-10, which is a ground support aircraft, and the F-15. And his theories are a basis for this maneuver warfare that we used in Iraq when we attacked then. And all of this theory kind of gets boiled down to an OODA loop. So this OODA loop is the framework that I wanted to talk about a little bit, because I'm going to place the graph model that we utilize in this OODA loop and talk through some of that. This is a picture of an OODA loop. You may have heard of it, may not have, either way. What's interesting about it is if you really start to utilize it as a framework to hang some of your mental model off of as you look at security or even a lot of other things, I think it becomes very useful. And I found it to be a great way to talk about some of the systems that I have the opportunity to build and others build and place into the security context. So OODA, short for observe, orient, decide, and act. And if you look at what a typical security team does in the security tools, they go through this process. So observe would be everything from, I'm going to collect some logs. I'm going to go out and pull some APIs. I'm going to do a network scan. In this particular instance, one of the tools that I have actually receives a stream of configuration changes for the cloud. So those are observations. They're kind of facts. We have to get all of those things. We have to put them into a model, a mental model, or an abstraction, if you will, so that we can orient ourselves, so that we can actually take all that information, those facts, and put them together so that then we can make decisions and then we can do actions. So if you think about what a typical SOC goes through, they're doing various versions of this. They're going through looking at observations. Really, they're looking at a model, and they're getting some kind of event or an alert that says they got to make a decision, and sometimes they'll go back and look at their orientation model, and then they'll decide whether to act or not. This model is useful for a lot of different things. To give you a sense, if you were going to play a game of chess, you're going to go through this model. And, you might have a move, or your opponent has a move. You'd put that into your mental model, like, oh, that's going to affect the center of the board. I need to react to that. So now I've made a decision, and now I'm going to do an action. And you go through this. And that's why it's a loop. And Boyd was all about tempo and time, and says if you can go through this loop faster, you win versus your opponent. And I think that's a good analogy for a lot of what we do in the SOC. We have things like mean time to detection is a good KPI. Mean time to resolution, going through this entire loop is mean time to resolution. If you can do that faster, you're better off. So this journey, I got attached to InfoSec. I'm an innovation guy. I get to build systems and try out new things. And one of the things that came up was putting a graph here in this orient model at this stage. And this is what I'm going to talk a lot about today. I'm really not going to talk too much about decision and actions. I think they're a little more proprietary and specific to what we're up to. But suffice it to say, we run logic against this core model, and then we do our actions, and we have tools that do certain parts of this. We have a SOAR tool, we have automatic decisioning, and we have people getting in the loop there too. We have all sorts of observations, from log files to config files to we have Expanse, which goes out and looks at everybody from externally. So there's all sorts of inputs into this type of a model. So when you think about that orientation model, all of us have one if you're in the security business, and you're dealing with them all the time. And I think there's I think there's some issues with some of the tools that we use as them being the only model that we have. So what's your abstraction? How are you orienting? What are your tools dictating here? When I first went through this process and was coming up with a system to try to do some real-time stuff, I looked at Spark, and I looked at a thing called Flink, which does some event processing and all those types of things. But a lot of it ended up in SQL. And when you end up in the SQL world, you start ending up with lists. And the lists, in my estimation, dictate the abstractions and dictate the way that we can actually orient. So, if you look at what happens here, the core abstraction for a lot of security is basically a tuple with a timestamp. So that's basically a log entry. And this is flexible because you can correlate via multiple timestamps. So if I have timestamp 1, I got timestamp 2, and they're close, I can actually put those two tuples together and build up my abstraction. And this is what we do in a SIM or with SQL. Obviously, you can use some other fields too, but basically you end up with lists. So I want to know, firewall rules for this particular project. I got to build that up, and then I can get a list out of it. If you look at using a graph in this particular place, you can actually start getting to, instead of having a tuple, which is basically just a log entry, you can look at property nodes. So now I've got a node, and I've got edges, simple edges that connect to other nodes in my model. We build these, on write. So there's some effort involved up front. We actually, when we use this model, whether it's rather straightforward, but the abstractions are from the domain. So when you look at what I'm going to show you here in just a second, basically what I've done is I've said, okay, Google's got a model of the cloud that they've built. It's their particular cloud, and it's what they give us to utilize. And we can use their model and actually just reflect it. And so this is kind of stealing out of the industrial space, where they take complex systems and create a model that looks like the complex system, which they call digital twinning. So in essence, what I'm going to show you here is an orientation model that is a digital twin of the Google cloud platform. To give you an example, this is a feed event that comes out of GCP that I utilize. So they send me a stream of these, and then we put them in the model. But I kind of wanted to show this because if you were going to take this and model this particular event, you could do it as a log entry, and it'd be straightforward. And I could put all of these into a field. I could put them in BigQuery. I could put them into, a SQL database, or maybe even a NoSQL database. There are all sorts of options. But if you start looking at this, as I go through these fields, I've got this thing called an asset. This particular event, let's see what it is. Oh, this is a firewall rule. So I've got an asset type. It gives me the type. If it's a firewall rule, it gives me the name of the firewall rule, and then it starts talking about all of these particular attributes of the firewall rule. When you look at what I'm going to do in a minute, I'm going to turn one of these into a node, and I'm going to put all these attributes in the node. Very Neo4j, it's a property graph, so the nodes can have attributes, which will be all of these things. But what's interesting is if you look here at ancestors, this is actually a hierarchy. So this is how Google actually models their resources. So I've got a project that's in a folder, that's in another folder, that's actually in an organization. So I have this hierarchy. Flattening that out and putting it in a log is, in my estimation, losing a lot of information and the ability to actually eventually walk this hierarchy, which we typically want to do when we have an alert. So there's some things that really come out of this when you start thinking about how you're going to model an event that the graphs, in my estimation, are very helpful at. One of the things that happens, I started to talk about, we write on ingest. So you start to worry about speed and some things of that nature. We're a pretty large GCP shop. We have 50,000 plus projects. And, this is our requests per second over the last 7 days. So we not all of these by any stretch end up in the core data model, but they at least have to be filtered and looked at some level. So, we're hitting up to 200 plus requests a second. So it's pretty sizable. I mean, obviously, if you're doing network flow logs or something like that, that's a whole different orders of magnitude, different type of tooling. But this data is a little more valuable. So if you look at the, every one of these events, in my estimation, is more valuable than maybe some other types of data streams. But it scales very nicely. What I'm going to show you actually runs on simple, straightforward VMs. It's pretty cost effective too. The project's called Project Archimedes, which is pretty irrelevant to everyone, but that's our internal code name. And I'm going to show you the architecture of it from a GCP perspective. Excuse me. If you look at the central part of this, we have a graph database. All of this stuff over here, this is the, when I had that OODA loop, this is the observe side of the house. This is the orient, which is where we have the model. And then over here is basically decide and act. I'm not going to show you a lot of this. This is just our cloud functions where we can run business logic and run queries against the graph database. And then we actually go out to one of our SOAR tools, which is our orchestration tool. But the gist of it here is pretty straightforward. Google has a thing called asset inventory, which is a representation of every resource in your entire organization. So the entirety of your cloud. It's everything from a BigQuery table to an instance to a firewall to a network to a route, all sorts, everything that you have to configure and can create and actually pay for is represented as an asset inside of GCP. They'll expose that as a pub/sub feed, so I can actually get a real-time stream of anytime anything changes. So that's what these represent. I have asset inventory, so I set it up at the top of my project, my organization, excuse me, and I receive IAM feeds and resource feeds. So I get changes from all 50,000 plus of our projects. Anytime something changes from a resource perspective, whether usually that's a create, an update, or a delete, that shows up here at our door. We have a loader that actually reads from the pub/sub queue, posts it to the Neo4j graph database, and actually creates a digital twin of the resources that we're interested in. Once it's actually transacted into the database, we actually throw that event into another pub/sub, which actually triggers our alert logic. So these are all cloud functions. So let's say I have let's say I change an instance. Instance comes through, it's a resource feed. It comes through the loader posts it to the graph database. The graph database puts it into the appropriate spot. hence the orientation model. So now I've got a model of the world as it exists at that point in time. I take that event, put it into a new pub sub, and I trigger all of the relevant logic that we want to run against that type of event. So at that point in time, I might want to go and say, hey, I got a new instance. I want to go look at, from my NICs to my subnets to my networks and my firewall rules. And I want to evaluate all the firewall rules. So I'm going to go pull all the attributes out of those firewall nodes after I do a complex query, which if you tried to do in a SQL, you'll fall over. It'll do it very quickly, especially if it's indexed. And if the logic says, if the decisioning says that we need to trigger an alert, we'll do that, and we'll put it out to our decisioning and action space, which is actually typically involved with people, unless we're doing auto remediation. So we do have some auto remediation that goes through quickly. And in a real-time system, real-time remediation for certain things is very good. All right, let's look at some demo. Just a second. All right, so this is a Neo4j screen. Basically, this is the tooling out of the box. This is the general admin UI where I can go look at what's inside of my Neo4j graph. So I have a simplest of entry points here. This is a Cypher query language. And basically what's occurring here is if I run this, I get one node back. So I said, okay, graph model, give me all organizations and return it. I know I only have one organization because it's the root of my hierarchy. And the hierarchy here is hutco.org. So this is my demo environment. So this is, if you're familiar with GCP, you have an organization that have folders that have projects, and projects hold resources, which are cloud resources. So what's interesting is if I start to expand this and start to walk the tree, what you'll see is my organization has projects and it has folders, which are the green things, and you can tell what they are from up here. So I've got a demo folder, and in my demo folder, I have a connections project. So what I just did, this is something that I set up prior to us starting today. But this is basically what I'm talking about is my digital twin. So I have, basically this is what GCP has given me as how they organize their services. And I've mimicked that into a graph model. And so what's cool about this is obviously it's nice to be able to look at it, but it's also interesting that we have the basic connections so that I can actually query relevant information. So I'm going to go and I'm going to focus in on very specifically a query that is just the connections project. So that's, I walked that hierarchy down, which is kind of the general overview of GCP and how that works. And now I'm just going to go ahead and go in here and look at this particular project. And I'm going to start this just because I'm going to show you what it's at now so we can go through and look at some real-time type stuff. So this project is called Connections. It lives in the demos folder. It has a parent, which is demos. All of these nodes have, this is a firewall rule. If you look down here at the bottom, this is a property graph. So I've taken all of the actual data that GCP gives me and for that particular firewall rule. And you can see all of the things that I can query against, or if there's things I want to look up, all of this stuff ends up in the property graph. If you were to go out, you can actually query Google's API on demand. And sometimes it's useful to go do, and you would get this exact same information. But what it's not done is it's not connected to all this other information. So the graph model gives you the ability to now walk all of this context. So what type of thing might I worry about or care about? Well, let's say I've got a firewall rule and there's something wrong with it. I might go back up to my project and I might look at a policy, which is now relevant from a, this is where roles and privileges and IAM and users actually start to interact. So now I can actually query all of these other attributes and objects. I'm looking for a specific one that's actually me. It's always the last one. So as you can see, this is actually, I am a role owner. So if you look at this, user Hayes at hutco.org is got a role owner. So if I had something that was wrong in a firewall rule, being able to query and walk this hierarchy in order to find something like the owner is context that we actually do. So we'll actually run those cloud functions against this model after an event triggers. And if we get something that's wrong, we'll actually come back in and we'll start walking some of these trees in order to accrete even more information before we create an incident. So I'm going to reset this query so I don't have all of that stuff in there. And if you'll look, one of the things that I don't have currently is an instance. So I'm going to go ahead and go over here and create an instance. This is the Google Cloud Platform console. So I'm in a particular project. I'm in virtual machines and VM instances. And so this is just the cloud console that all clouds have. And I'm going to say, okay, I want to create a VM instance. So I'm just for sake of time and arguments here, I'm just going to go through this quickly and take the defaults. But I'm in connections. It's going to be called instance 1. It's going to be just, I'm going to create a couple of firewall rules. So this actual thing here will actually do a few things. It'll create more than one node and edge. It'll create a few things. So as it's coming through here, this actually takes more time than it does to get it into the model and to react to it. So what's nice is if you have certain high value things that you know just out of the box are no-goes that we can detect, we can actually run a real-time alerting here, and actually instead of even putting it to an operator, we go ahead and do auto remediation. And depending upon which part of our cloud we do it more so in dev than we do it in prod. That's pretty typical. So now that this thing is created, we can go back over here. And if I rerun this, we should see that we actually have a new instance. It didn't give me a pretty name, but I'll pick one. And this instance is connected to a NIC, and this NIC is connected to a subnet, and a subnet is part of a network, and a network in the GCP world is where the firewall rules are. So now what I just did is, at this point in time, now that I've created an orientation model, I've integrated the information in, it would have gone out and it would have triggered a bunch of cloud functions to actually come in and evaluate these using the Cypher query language to walk these nodes and edges in order to look at the attributes. So this particular instance would have created this entire chain in order to look at things like, what does this particular firewall rule allow? And so this particular firewall rule looks like it does TCP ingress port 80, and we may not like this, right? This is custom allow HTTP kind of out of the box. In a particular world, we would be probably relatively unhappy with this. And in this type of an instance, we'd probably shut this down immediately if you could even create it. And that's kind of the real-time beauty, because this type of scenario that I just showed you here, the out-of-the-box GCP console, the cloud providers are in the world in the game of, hey, let's make this easy and make sure everybody can use this. As a security teams, we're in the world of, hey, let's do stuff smart. And this particular instance would have been immediately shut down. And you saw by the time we got here, all of this new information was here, which hadn't been there. And in that same breath, we would have triggered that evaluation steps too. So you get that entirety of the real time coming through. And that kind of harkens back to my OODA loop, which is, let's get through this, let's model our data and orient correctly, and then let's add speed. So that's kind of the entirety of that project. And I think it's going to continue to grow. You see graphs in our industry in multiple places. It's a great way to model your orientation because I can actually bring in a whole lot more objects and attributes and connect them into this framework that I've already got that has all the pieces that I need. And by doing that digital twin, I actually get the benefit of mimicking what GCP has. So like things from a documentation and understanding perspective, all of these entities that are here on the screen actually match up with what GCP actually provides. So you can go look at the APIs for this and understand exactly what all these fields and attributes are because they're just straight pulled from GCP, and we're just reflecting them in a new model that's actually a lot faster and it's already connected in real time. So I think that's about all I've got. Appreciate everybody's time. Don't know if there were any questions or anything of that nature that we wanted to see if anybody had at this point.
Hi, Hayes. It's Marilee. Thank you so much. I love that whole concept of the OODA loop. I think it can be applied to so many things in life. And my daughter likes to play chess, so I'm going to have to ask her if she knows about the OODA loop. Incorporate that into her plan.
Well, it's a nice model to hang things off of because it gives you a place to put the different pieces.
Absolutely.
As a person who designs systems, having pieces in their good places that have been thought out at a high level makes good sense, and it helps talk about them.
Yeah. So I want to let the audience know that if you do have questions, you can type them into the questions tab located at the top of your screen. If we don't get to your question, someone from Neo4j will reach out to you directly, or you can send your question to webinar@neo4j.com, and we will get you pointed in the right direction. But we did have some questions that have come in while you were presenting, Hayes, so I want to get started with those. And this one talks, and you touched on this, but I want to come back to it. It says, you've shown a lot of GCP, but what about the other cloud providers?
Sure. And that's a good question, and it comes up a lot. There's kind of a holy grail, and we at Palo Alto do a lot of multi-cloud, so we go across clouds. I showed GCP. The general ideas work across all the clouds because all of them are structured very similarly. I mean, a project in GCP, which is where all the resources hang off, is very similar to a subscription or a resource group in Azure or an account in the AWS parlance. But I think what you'll find is you have to kind of build the model for each of those. And while they'll look very similar, and they really will, ultimately you'll end up with some simple hierarchies, some are more hierarchical than others. You got to get to a place where those resources fit in and those attributes tend to be very different because they all kind of do things at a low level a little differently. So, we'll have some real-time AWS stuff, and it'll be similar to the way this works, but it'll have its own object model. So it'll be an AWS hierarchy instead of a GCP hierarchy, because once you try to abstract them too much, you lose some of the real individual pieces you have to have in order to make good decisions. So I got perfect examples like HashiCorp with the Terraform. I don't know if you know that tool. It's a CI/CD tool where you can, try to abstract the language and then say, hey, you can go build all these things. But ultimately, they still have a plugin for each one of those cloud providers. So you kind of still have to get to the nitty-gritty details of each of them because they all do things just a touch different.
Of course, wouldn't want to be the same. Just each of them have their own little idiosyncrasies.
Yeah.
You mentioned something about real time, and here's a question that asks about: has real time really helped you, and is it worth the effort?
Sure. Yeah, and that's a good question. The long and the short of that is it is helpful, and I'm convinced that it's going to continue to grow as there's more stuff to deal with. And as we become more comfortable with automating responses. So if you looked at the OODA loop, right, you've got the observations. They're coming. A lot of them can come in at real time. So we're getting real streaming logs. We're getting real configuration changes. I'm putting them into this orientation model that's doing this real time stuff. So I can give you up to the second. Here it is. This is what it looks like. And then we're going to throw it into an analyst's queue. Well, I just put a person in the loop, and there's just no telling at that point, unless we're ringing fire bells and that type of thing. The real time isn't as important in that situation. But that being said, real time can support that situation, and it can also support the alternate, which is real time automatic remediation. I'll give you an example from internally. We first started this project. We ran some ports were open on creation of some things that we didn't like at all. And we had 30 or 40 projects in the first month that we were auto remediate closing. Not only did we auto remediate fixing it with a hammer because it shouldn't have been done, it was bad practice. We actually did communication. So we walked that tree, got some of the owners and the people that owned. You could go look at tags if you had tags in your environment and those types of things. And you could find out who's accountable for this action and activity. And immediately at the same time, out went a bunch of communications. Don't do this. Suffice it to say, 3.5 months, maybe 4 months later, we have zero. It doesn't happen anymore. We've changed behavior across thousands of developers because of that real time. Because that immediate feedback loop let them know not only were we watching, not only was it concurrent with your activity, and we communicated up your chain, it's like this whole set of things occurred immediately. It really was a game changer from a behavioral perspective. Plus, our vulnerability stance went, from that perspective, went way down too, that dimension. So real time is good. It's going to continue to grow as we get more comfortable with things that can be filtered on the bottom that are just stupid. Let's just take that, automate those away, automate the things that are hammers that we know we have to do immediately, and then let's free the sock up to do some the gray stuff, the stuff that a human's good at. And the real-time engines will still handle that because, we can still report it. It can get queued up behind a human if we need to.
Great, thank you.
Yeah, so I didn't finish. Is it worth the effort? Yeah, I think so, and I think it's going to continue to grow to be worth more and more the effort. And if you take Boyd at his word that cycling through that OODA loop faster is how you win, then you have to go there eventually at some levels. I mean, it's just there's so many threats. You have to. Mm-hmm. So yeah, yep.
Well, thank you for that explanation, and I'm just fascinated listening to you talk about all this. I wish we could continue on, but I think our time for the session has come up. So I'm going to thank you, Hayes, for being here with us today. It was such a great presentation. I really appreciate it.
Well, I appreciate everybody's time.
And for those of you in the audience, our next session will be starting shortly, so stay tuned for that. Thanks so much.
Cheers.